We're going to be looking at example 3 in your section 4.1 notes. So our job in example 3 in both A and B is to sketch a graph of f that's continuous on the interval from 0 to 4. So let's see in part A what we need to do. So the first thing that we need to do is we need to make sure that the derivative is 0 for these three values. So what that is telling you, the derivative, remember that's a fancy way to say the slope. Okay, so we're going to need horizontal tangent lines for those. Okay, so the absolute lowest spot, because it says absolute min, is at x equals 1. Okay, we have no local min or max at x equals 2, so we'll just make a note that we don't want any highs or lows there. And then finally, we want an absolute max, so this is going to be a high spot at x equals 3. Okay, so let's go ahead and get our increments from 0 to 4 drawn on our graph. Okay, so at 1, we want a low spot, so it doesn't really matter where we put it. We'll just put it down here somewhere. Okay, at 3, we said we want a high spot. Okay, at 2, this is the weird one. 2 can't be a high or a low, okay, so we're going to put it somewhere in between. We just want to make sure that when we draw that we have a slope of 0 that occurs there, okay, because of the first condition that we have. Okay, so I'm going to go ahead and start drawing at 0. Make sure you use the filled in dot because of the brackets that are given to you. Okay, so that would be your low. That would definitely have a tangent line that has slope 0. Okay, as I'm coming up to 2, I'm going to slide through it this way, okay, so that I can make a tangent line that has slope 0. We're going to discover that this ends up being an inflection point later in the chapter, okay. And then we're going to go ahead and go on up. We want to make sure that 3 is our high value, so we definitely have a horizontal tangent line there. Okay, and then we'll come back down and finish at 4. Okay, so something like that. That's a pretty rough sketch. Make sure there's no point values, because we know that derivatives don't exist at corners, so try to make it as smooth as possible. Okay. All right, so let's now take a look at example B let's look at example B here for number 3. Okay, so on this one, we have that the derivative, which again is the slope, is 0 at 1 and 3, okay? All right, we know that the derivative of 2 is undefined, so, maybe make a corner here, okay? We can't have a break in the graph because of the given continuous property. We know that we have a high point at x equals 2, and we have neither a min or a max at x equals 1, okay? We have a low point at x equals 3. All right, so putting this together here, so going ahead and marking my units. All right, so we have a high point at 2. We can go ahead and make the dot for that. Okay, we also said that that high point, that the derivative doesn't exist, so maybe go ahead and make a sharp corner, something that looks like a V there. Okay, we said our low point occurs at x equals 3, so I'm going to go ahead and put my low value down there. Okay, and then 1 we said has neither a min or a max, so it's going to be similar to what happens here. Okay, so we'll go ahead and put the dot in between our high and our low. Okay, we'll go ahead and start. So we'll come up, kind of slide through it, so we have a horizontal tangent line. Okay, connect, we can see our sharp point. Okay, go ahead and draw down. We want to make sure that this is a nice U shape, okay, so we can find the derivative there. and then we end somewhere at 4. Okay, so filled in dots to start because of the continuous on 0 to 4 condition. And that completes example 3.